last lecture we have studied about the centroids of the particular shapes. Now centroids of particular shapes by first principle. So to determine the centroids by first principle, we know that here when we find out the formula of centroid, here we have taken the movement about a reference line of area, movement of area about a reference line. So here by first principle for a rectangle, we also take movement of area about a reference line. So this is, we have taken a reference line at x-axis, and from here, from the reference line, a strip, an elemental strip is taken at distance y. The thickness of the strip is dy, and this side is b. So now, first of all, area of the strip. Area of the strip is, this is b and dy. So b into dy. This is the area of the strip. Now the movement of this area about x-axis. So this is the area, b into dy, and this is distance. So if we multiply this area of the strip with this distance, then it will give the movement of this area of the strip about this x-axis. So this is equal to b into dy into y. So this is area, this is distance. So this is the movement of the strip about x-axis. Now, if the total area of this figure is a, and it is equal to b into y, b into h. H is the height, b into h. A is equal to b into h. So total moment area for this area, movement of this total area about this x-axis is a into y bar. Y bar is the distance from this x-axis for this total area. So movement of this total area about this x-axis is a into y bar. So this is equal to the integration of this area, elemental strip, into y. This is the moment of the strip about x-axis, and this is the moment of the total area about the x-axis. So we can equate this, and the limit here is 0 to h. 0 to h. Now integrate it. So b is the constant, and y square by 2 is the integration of y dy, and limit is 0 to h. So on putting the limits, b into h square by 2, and add in place of a here we can put b into h into y bar. So y bar is equal to b will cancel this b, and h will cancel the power. So y bar is equal to h by 2. Similarly, x bar equal to b by 2. For this, we have to take the vertical strip like this, and distance is x, thickness is dx. So here a into x bar is equal to 0 to limit b, and here h into dx into x. So this will give you h into x square by 2, or limit is 0 to h, 0 to b, limit is 0 to b. So this will give you h into b square by 2, or here h into b into x bar. So from this we can say x bar is equal to b by 2. So like this, from first principle, for a rectangle, x bar is b by 2 and y bar is h by 2, as we have said earlier. So by applying first principle, we can find out the centroid by taking the moment of the area about the reference line considered. Now, the centroid of a triangle by first principle. So this is a isosceles triangle, and this is symmetric about this line. So the centroid will lie on this line. So we have to find out the distance of centroid of this triangle along y-axis, that is how much it is distant from this reference line x-axis, because due to symmetry this is lying over y-axis. Now we have to determine the distance from x-axis. So from first principle we have to take an elemental strip at a distance y from this line of thickness dy. So total this height of this triangle is h, and this distance is base b. So this remaining height, or the height of the smaller triangle, is h minus y. Now the area of the strip, suppose this is x. So area of the strip is x into dy. Now to determine this x, we have to follow the property of the similar triangle. So to determine this x upon b is equal to h minus y upon h, corresponding side, h minus y upon h. X upon b is equal to h minus y upon h. So this x is equal to h minus y into b upon h. H minus y into b upon h. Now I'm putting here area of the strip dA is, in place of x, b into h minus y upon h and into dy. Now the moment of dA about x-axis or reference line, dA into y, or b into h minus y upon h into dy into y. Now for total area A into y bar. Y bar is the distance of the centroid of the total area. So this is moment of area, total area, into y bar is equal to is the moment about x-axis. This will be equal to integration of this from 0 to h, b into h minus y over h into y into dy. So upon integrating this, e is the constant and this is one minus zero to h, 1 minus y upon h into y into dy. Or this will be equal to b, y goes inside and after integrating, y square by 2 minus y cube, because this become y square, so y cube by 3h, and limit is 0 to h. On putting limit, y square in place of y square, h square by 2 minus h cube over 3h. 0 will give you the 0. So b h square by 2, and from this h here 2, so minus h square by 3. So this is equal to b into h square by 6, and from here in place of a, area of this triangle a is equal to 1 by 2 into b into h. This is the total area. Total area. So on putting this on left hand side, a is equal to 1 by 2 into b into h into y bar. So y bar is equal to h square by 6 divided by h by 2, or this is equal to h by 3. So as we have told earlier, this y bar is equal to h by 3 for this triangle, and x bar is equal to 0, because the line of symmetry is taken as reference line. So reference line is, these are the reference line, this reference line and this x-axis reference line. So centroid is lying over here. So this is h by 3 and this is 0 from this reference line. So this will give you the centroid of triangle. Now for a circle. Now for a circle. So this is a circle, and these are the two reference lines. This is x-axis, this is y-axis. Now for this, centroid is lying here. So here x bar is equal to 0, y bar is equal to 0. Now for this, we have to take elemental strip like this at theta angle and making an angle d theta at the center. So radius of this circle is r. So this will be r d theta. So suppose this is a right angle triangle. So to find out the area of this strip, is equal to area of the strip. dA is radius base. This is base. So 1 by 2 into base into this height or d theta. So dA is r square d theta by 2. R square d theta by 2. Now the moment of this area about this x-axis. We have to find out the moment of this area about this x-axis. So we have calculated earlier the centroid of the triangle. The centroid of the triangle is, from here it is r by 3, and from the center it is 2 by 3r. So we have to resolve this distance 2 by 3r at this x-axis, because we are taking the moment about this y और x-axis. एक बार x-axis के about moment लेंगे, एक बार y-axis के about. So now we are taking the moment about y-axis. So this is equal to moment of this area about y-axis. So this is equal to dA multiplied by 2 by 3r into cos theta. This distance is, suppose this distance is 2 by 3r. So we have to take the distance along x-axis. So this distance is 2 by 3r. This distance is 2 by 3r cos theta. This distance is 2 by 3r cos theta. So we are taking the moment about this y-axis. So for y-axis, dA into 2 by 3r cos theta. Now the moment about y-axis of total area. So A into x bar. A into x bar is equal to integration of 0 to 2 pi and dA into 2 by 3r cos theta. Put the value of dA 0 to 2 pi in place of dA r square d theta by 2 into 2 by 3 r cos theta. This can be written as 0 to 2 pi r cube by 3 cos theta d theta, or on integrating r cube by 3 constant, and this is sin theta 0 to 2 pi, or it will give you r cube by 3 into 0. bar is equal to 0. Similarly, movement about x-axis. Similarly, movement about x-axis. So dA multiplied by 2 by 3 r sine theta, because now the vertical distance is required. 2 by 3 r sine theta. This is also 0 to 2 pi, or this will give you in place of dA r square d theta by 2 multiplied by 2 by 3 r sine theta integration, or this will be r cube by 3 minus cos theta 0 to 2 pi, or r cube minus into 0. So y bar is also equal to 0. So as we have given you earlier, it has been proved that x bar is equal to 0 and y bar is equal to 0 for a circle if the reference lines are passing through the center. Okay. Now for a semicircle by the first principle. So semicircle is like this. So this is symmetric about this line, and second reference line is this along section line. So this is y-axis, this is x-axis. Now as in case of triangle, again we have taken this is r d theta, and this is r radius. So for this again we have to find out the about y-axis. Actually this is the line of symmetry, x-axis. So the centroid will lie over this line, but we have to find out the distance of the centroid from y-axis. So for this we have to take the moment of this elemental strip area about y-axis. So as earlier, area of strip is r into r d theta by 2, or r square d theta by 2. This is dA. Now movement about y-axis, dA into 2/3r cos theta. Now for total area, this is A into x bar, and 0 to, or limit will be minus pi to pi, minus pi by 2 to pi by 2, because this is the origin, and minus pi by 2 this side and plus pi by 2 this side. This at this 0, so angle is minus pi by 2 this side and plus pi by 2 this side. So for this, r square d theta by 2 into 2/3 r cos theta, and this will give you r cube by 3 sin theta minus pi by 2 plus pi by 2. What this will give you r cube by 3 sin pi by 2 minus sin minus pi by 2. So r cube by 3 into 1 plus 1. So this will give you 2r cube by 3, and total area A for semicircle is pi r square by 2. On putting at left hand side, pi r square by 2 into x bar. So this x bar is equal to 2r cube by 3 divided by pi r square by 2, or this will give you 4r by 3 pi. So by first principle, it is as given earlier, x bar is equal to 4r by 3 pi and y bar is equal to 0 due to symmetricity about x-axis. Similarly, for a semicircle also, it can be done for a semicircle. Oh, quadrant. So this is for a quadrant. Quadrant is like this. This is a quadrant, and these are the reference lines. This is along x-axis. This is along y-axis. Now similarly, as earlier, elementary strip is like this, and this is r d theta. So the area dA for elemental step is r square d theta by 2. Now about y-axis, moment about y-axis, dA into 2y3 r cos theta or on putting the value of dA r square d theta by 2 into 2y3 r cos theta. Now for total area A into x bar is equal to, now the limit will be 0 to pi by 2. Here 0, here pi by 2. So limit is 0 to pi by 2. And this will give you r cube by 3, r cube by 3 into cos theta d theta. So this will give you r cube by 3 or sin theta limits 0 to pi by 2. Or this is equal to r cube by 3 sin pi by 2 minus sin 0. And total area, this total area is pi r square by 4 because it is a quadrant into x bar, and this is r cube by 3. So this will give you x bar is equal to this 4 here, so 4r by 3 pi. So this is for quadrant x bar. Similarly, we can find out y bar also, which will come out also 4r by 3 pi. For this, we will take movement about x-axis. And for movement about x-axis, vertical distance is required. In vertical distance, this will be 2 by 3r sin theta. Limit will be the same. In place of sin theta, here cos theta will be there. Okay. Cos theta will be of minus. So when we put pi by 2, it will become 0. And when we put cos 0, it will become plus 1. So this will again r cube by 3. And again y bar will be equal to 4r by 3. So as earlier we have said, x bar is equal to 4r by 3 pi and y bar is equal to 4r by 3 pi in case of quadrant. So both are 4r by 3 pi in case of quadrant. Now next topic we will discuss in next lecture. Okay, thank you.